Okay, so this is the screencast for 2016 paper 1, question 5. Now, I'm just looking at it straight off. Again, I'm assuming you've attempted this question in advance, so you have a fair idea what's going on. But we have a table here with a collection of terms. Now, second I see term, I have a fair idea this is to do with sequences and series. Shows the maths tables later on where that is, but there's a few formulas that govern this, but also there's two different things. There's now either arithmetic sequence or geometric sequence, usually arithmetic to be honest, and you'll be looking for some sort of pattern in the numbers themselves. So even without looking at the question, I'm going to just see, can I identify the pattern? First term is 13, second term is 15, third term is 19. It's going up by a difference of 2, then by a difference of 4, then by a difference of 6, then by a difference of 5 and 3 is 8. So you can see there each time, the jump each time is 2. Okay. And now that would give an indication that it's quadratic, but that's down here in one of the questions below. My next one should be difference of 10, so it should be 43. Next one then should be difference of 12, should be 55. Now, if my maths is correct, which hopefully it is, I'm embarrassed myself. Next one was 12 and 2 is 14. I think it'll be 69. Okay. Now, I suppose I should learn a lesson here. I should always read the question. A power 1, follow the pattern of the table above to write the next 3 numbers into the table. As far as I'm aware they're right, but I have the answer built in here. So I've overlaid there the 3 answers, so I was right. And the explanation is there. I hope that's fairly obvious. The pattern isn't outrageously complicated. And part 2, then use the data in the table to show that the pattern is quadratic. Okay. So the first difference is 2, 4, 6, 8, 10, 12, 14. So we saw that 2, 4, 6, whatever. Now the second difference between the difference, is 2 each time, which is the pattern there would say that the second differential, whatever, is quadratic. Now I find those questions incredibly hard to answer. It's pretty advanced knowledge, but with a quadratic, when you drop it down to the next layer, it becomes linear. When you drop it to the next layer, it becomes a constant. So that is the basic gist behind that question. Now, when I first came across this, I had no clue what was going on. It's something that's kind of new for Project Maths, the way they're approaching that. I'm assuming you came across it in your books as well. But even if on a day they didn't get that question, if you wrote down something to indicate what a quadratic was, okay, you might get some marks for that. We look at the marking schemes built in at the end of the question, so we can maybe look back at that. That's question A, part 1 and 2. Okay, part B then. Now again, I'm assuming you've given this a go at least. Okay. Now this is pretty tricky, but you have a statement here. Now it's given to you. There's no numbers. Okay. But this here on the right hand side of it, I can recognize that's a quadratic function, or quadratic part. Okay. I know that because it's the power of 2 on the variable. That could be x, but in this case, they're using n. Okay. Now they're saying b and c, the two numbers here, are elements of z, which means they're integers. Okay, they're positive or negative whole numbers. Okay, and you're asked to find what b and c are. Now go to the answer because, to be honest, it's hard to know what to do to start this. Okay, what you might start doing is by going, well, I don't know anything about it, so let's try pick random values of n and just throw it in and see what happens. Okay, now I've done it here, I suppose. I found u of 1. Okay, and I know that's 13 because that's what's given me in part A. Now that's a big leap, whatever. But A, B, and C parts can be mixed together. So when I put 1 into my statement, okay, the UN you put in 13 instead, and you put in 1 instead, which leaves you, when you work that out, you have an equation of 2 unknowns, which on its own is not solvable. And you're kind of going, maybe I'm going down the rabbit hole here. But if you go again, if you have maybe just you know what to do here, or you might be BSing, put 2 in instead of the n. Okay, exact same thing. You know that u2 is 15. So put the 2 in instead of the n, and put the un equals 15. So you end up here. when you resolve that down, you end up with a second equation of two unknowns. Now, hopefully, if you get that far, if you got that far, you've done well. But two equations of the same two unknowns, you can find out what those unknowns are by using the method of simultaneous equations. What I'm doing here is I'm doing the elimination method. There's two different ways of doing the substitution method we'll come across in another question. But I have my statement here. Okay, now it's not x and y, it's b and c, but it's the exact same thing. If you want to swap for x and y, you can, if that makes you more familiar. But I have to try make one of the variables, either b or c, equal in size, but different in sign, so they cancel. Now the easiest one there is to look at the c's. I don't have to increase their size. I just have to change the sign of one of them. I'm choosing to do this one by changing the sign of the second equation. So I can do that by multiplying across each term by -1. So the top equation stays the same. Bottom equation, 11 by -1 is -11. 2b by -1 is -2b. And c by -1 is -c. So I've just changed the sign the whole way across. Now the c's will cancel. Okay, so plus c minus c is 0. b minus 2b, okay, is the same thing as -b. 12 minus 1 is plus 1. So negative b equals 1, then change the sign across. Again, actually, what I'm actually doing is multiplying by -1. I just haven't stated it there. I end up with b equals -1. So I found one of the two unknowns. Okay, so I'm halfway there. I've found b. Okay, go ahead then, use that value in either equation, top or bottom, doesn't matter. I've chosen to do the top one here. Okay, I put b in instead of -1 instead of b. Now I have an equation of one unknown. Solve it out. Bring the -1 across the equal, change from minus to positive going across. 12 plus 1 is 13, so c is equal to 13, and that's my two answers. I could check them, okay, by putting b and c into either one of the original equations and seeing this left-hand side equal right-hand side. I'm not asked to do that, but I could just to make sure I'm right. And once I'm happy, I'm done. Label your answer. This kind of question that could end up making a lot of space in the exam paper itself, because if you don't know what you're doing, you're messing around the first bit, you ran out of space, and then you have to go use extra space. But that's just, sometimes that happens. So this is part B. Now part C, C says the table below shows the first 5 terms of an arithmetic sequence. Now this must be a different sequence. Yeah, okay. Find an expression for Tn, the nth term of the sequence. Hence or otherwise find the value of T30, the 30th term. Okay, so I suppose there's two parts to it. I have to find what Tn is and T30. Now I'm going to just go and see if I have it open. The maths tables. I had them open earlier. I've closed them down. I'll just get out of this for a second. And I have a digital version of the maths tables. I'm just going to open it up real quick. And I actually have it up open from earlier actually. So this is the page. So if I go back to the contents page, you'll see here different contents. Now we're looking at sequence series. Click on that, I end up on page 22. And there's information on the arithmetic sequences series or the geometric sequencer series. Okay, so I'm concerned with the arithmetic. So these are the formulas I'm really concerned about right now. Tn stands for the I suppose the total of the nth term, and Sn is the sum of all the terms. Okay, depending what n is. So it's the Tn is what I need. Now, if you don't know what you're doing and you just go Tn, I've seen that in the maths tables, write it in there. You're going to get something for it. Okay. Now I'm going to bring it back up to the slideshow, bring us to the answer. So what I've done here is maybe find an expression for Tn, the nth term of the sequence. I've probably done that here. I may actually have not done this properly, and I would have lost marks myself. But Tn, okay, if I take my formula back a step, so I'm going to go back to the previous page and just do that first part, which I think I've kind of haven't done. But Tn, they want an expression, okay? The A stands for the first term, which is 12, okay? Plus, now n, I can leave that as n minus 1, okay? And d is the difference, which is 2, 2, 2, 2. So it's 2 each time, so d is 2. And that's your expression. Okay, I could simplify it there by removing the brackets and getting Tn equals 12 plus 2n. So that's 2 times n is 2n. 2 times minus 1 is minus 2. And that would, the 12 and minus 2 would simplify to give you t of n, or Tn equals 10 plus 2n. So that's my Tn statement, okay, or expression. Now, if I find T30, I can put 30 into that. So if I find T of 30, my expression is correct. This should give you the answer. So it's 10 plus 2 times 30. So T of n will equal to, what's that, 10 plus 2 is 60. So 10 plus 60 is 70. Next, use the bad writing. It's hard to use this cursor yoke. So I think in my thing, I haven't actually given the expression like distinctly, clearly. What I've done on one side of it is I've said just use trial and error to go up and find the answer. Long-winded, whatever. The more elegant way is to find use your formula, plug your numbers in. So again, in the formula, the a is the first term, which is the 12. N is the nth, the term you're talking about, which in this case is 30. And 2 is the difference between each one. So we said that was 2. For an arithmetic sequence will always be constant. 2, it won't go 2, 4, 6. It'll be difference of 2, 2, 2, 2, 2. Now, geometric sequence the difference can vary in a geometric fashion. Okay, so that's part C. Tricky enough, but the formula is there. If you copy that, it's there. Here's the marking scheme screen printed in. Okay, they show the part A, part 1. I've done the 3 different answers. Okay, and part 2 then was the difference. Okay, the second difference was constant, so that's what implies as quadratic. You had your answer for the simultaneous equations, and then my my expression, and my actual calculation of the 30th term. Job done. I think that's the question. Okay, so question 5. Thanks very much. And again, go back over this in a few days' time, and it'll help cement the information. Okay, thank you.